In this video, we're going to go ahead and learn about operations on variables. To do this, we're going to be working in the viewDidLoad method, and we're going to go ahead and we're going to clean up the viewDidLoad method because there's a lot of stuff in there right now. So we can go ahead and we can remove all of our comments, and we're also going to remove the int x semicolon and then x equals 5 semicolon. We'll just rewrite that so that we can start nice and clean. So we're going to write int x is equal to 5. So once again, we're creating a variable named x that's of type int, which is short for integer, and we're going to assign it the whole value 5. Remember, all of our statements need to end in a semicolon. And we're going to create two more integer variables. So we're going to say int y is equal to 20. And let's create our third integer variable named z. We'll set its value equal to -2. And now we need to create two integers that are going to be used to capture the result of our operation. So let's see how it's done. Let's write int addition answer is equal to x plus y. And we can write int multiplication answer is equal to y times z. And now, in our first example, this translates to my variable named addition answer is equal to x plus y. Well, the value of x is 5, and the value of y is 20. So addition answer now has a value of 25. In our second example, we created a variable named multiplication answer. And if we look at the right side of the equal sign, we see y times z. Well, the value of y is 20, and the value of z is -2. So the value of multiplication answer is now equal to -40. Now we can go ahead and write a comment that's a little bit more explicit and helpful as to what we can do with operators. So we can write operators include, and we can say that we have access to the addition sign, the subtraction sign, the multiplication sign, as well as the division sign. We just use the addition and multiplication, but the subtraction and division signs work the same way. Now let's try an example using floats. If we wanted to know how far we must climb to reach the top of Mount Everest, we would first need to know the height of Everest. To do this, let's define the height of Everest. So we'll write float height of Everest, and we'll give it a value of 29,029 feet. Notice that while we declared the variable of the height of Everest to be of type float, we gave it a whole number as its value. This is perfectly legal, as the compiler simply adds 0.0000 after the number as a placeholder for future decimals. This is useful because the height of Everest may change in the future, and over time the mountain does not change in whole feet. So we might have to reassign the value of height of Everest to another float value. Now let's go ahead and calculate the distance we need to travel to reach the top of Mount Everest. So we can write float distance to travel, and we can set it equal to the height of Everest, and notice the autocomplete because we've created this variable already. And we can subtract the height of our base camp. Now, the float type variable named distance to travel is equal to the height of Everest, which is 29,029 feet, minus the height of our base camp, which is 16,900 feet, 0.3. So we now know the distance we have to travel to reach the top of Everest. If, however, we started walking 1,000 feet up our mountain, the value of distance to travel would change. In order to solve this problem, we can write distance to travel is equal to distance to travel minus 1,000. This is perfectly legal, although it might look funky and downright impossible in algebra. In computer science, though, this is legal and very common. Since we already gave the variable distance to travel a type, we can simply assign a new value to the variable named distance to travel. Furthermore, in our assignment operator, the right side gets evaluated first, so we have access to the old value of distance to travel before we assign a new value to this variable named distance to travel.